Okay, here is our problem set. Okay, so we're going to solve using each method. So up the top here, you can see that it shows partial products and standard algorithm. I'm going to do both just to show you, okay, and then just to see what you think, all right? So here's part A with the partial products, and this, I want you to think of this as kind of like breaking it into expanded form and then multiplying each one of those numbers, okay? So this is what this would look like for partial products. 4 times 4 is 16, right? I would just write down the flat out 16 here. And then I would do 4 times 30, or 4 times 3 tenths, and that would be 120. So I'd add 120 right here like that. Then I would add it up, okay? And watch this, I'd end up with, so this turns out to be 4 times 4 is 16, 4 times 30 is 120, okay? And then I just add up my products here, and I get 6, 3, 1, 136, okay? So that's what partial products looks like. Over here is the standard algorithm, which you know and you've grown to love, actually, how to do it. So let's just compare the two, all right, just so we have something to think about today. 4 times 4 is 16. We know that. So just like over here, I write down the 6, but in the standard algorithm, I carry that 1 over. I bring it up to the tens place here. Notice how I just left it right there in this one. And then 4 times 3 is 12. Add 1 is 13. I just write down my 13 here. So notice I end up with the same exact number, okay? So the way the standard algorithm does it, by carrying numbers, it's doing all of this in a tighter package, just a smaller way to do it, just kind of summing it up. But this is what we're really doing. It's called the distributive property of multiplication, okay? So the way I look at it is if we're doing this multiplication like this, if I say to you 34 times 4, let me zoom out just a little bit here, okay? I feel like it's super close up, okay? And what does that equal? Now, if I were going to do this in my head, how would I do it? I would say, all right, I would break this number into a 30 and a 4, okay? And then I'd multiply each of these numbers by this 4 over here. I would say, all right, what's 4 times 4? And 4 times 30. And I'd end up with, well, 4 times 4 is 16. 4 times 30 is 120. And I'd add those together and get 136. Just like I did over here, okay? So that's what the partial products is all about, all right? So again, do you need to know how to do this? No, but it's fun to kind of see what we're really doing. When we're multiplying 4 times 3, it's really 4 times 30, not just 4 times 3, okay? All right, on to the next one. Partial products first, okay? And this is the last time I'm doing partial products today, okay? So 4 times 3 ones, okay? That would be 12. So I just write down 12. And then 4 times 20, or 3 times 20. 3 times 20 is 60, right? And then 3 times 200. Well, that's 600. Okay? Then I would just add all those up. 2 plus zeros. 1 plus 6 plus 0. 672. Okay? Now here comes the standard algorithm. Okay? This is where we have to carry numbers, all right? So 4 times 3 is 12. So I put down that 2 and carry the 1, right? Instead of doing that. 3 times 2 is 6 plus 1. 7. See that? And then 3 times 2 is 6. Good. See that? So when I really did that 3 times 2 is 6, it's really 3 times 200, which was 600. So that's basically all it's teaching you, okay? We end up with the same numbers. Now the rest of this, okay, is you, and these problems right here, is you going through this and doing the standard algorithm, just like this over here, okay? Just like that. All right, I'll do the first one and then we'll move on to the back. Solve these using the standard algorithm. A, let me zoom in so we get a good view of this. 3 times 1, that's 3. Okay, that 1's in the 1's place, so that 3 stays in the 1's place. 3 times 5, that's 15, right? 5, 10, 15. I put down the 5, I carry the 1, right? Because that 1 needs to go to the next place value. And then 3 times 2 is 6, plus 1 is 7. So my answer here is 753, okay? And the rest you can do as a group, together, or by yourselves, up to your teacher's discretion there, okay? All right. Down here, or over here, is the product of 7 and 86. That would be this, 86 times 7, okay? I would do that here. Same thing over here, was 9 times as many as 457. Remember we talked about this way long ago, times as many, so 9 times as many. You're just multiplying 457 times 9. So it would look like this, 457 times 9, okay? And find your answer. Okay, now each one of these word problems is also a multiplication problem here, okay? And here as well, all right? So as a class, feel free to go through and work with these, read these together, solve the problems, do them on your own. It's up to your teacher's discretion there. I will, teachers, have an extra practice sheet, so when kids finish this, they can work on it. It'll be 4-digit by 1-digit multiplication, and it's a little harder than the one we did yesterday. The one we did yesterday just had 3s and 2s down here. Well, this one's got 8s, 4s, 7s. It's got all the way up to 9. All right, so this one's a little bit more challenging. So having that multiplication chart in front of you might be very helpful here, okay? And kids, I'm telling you, slow down when you get here. Once you start going fast is when you start getting confused, okay? All right, super proud of you kids as always. I want you to keep working hard in math class. Be good listeners. You have to listen to all this instruction and chew on the things that you don't understand. Give your brain a chance to catch up and think about it, okay? We don't expect you to know everything at that moment. We expect you to listen and let your brains catch up when they're ready, okay? All right, guys, we'll see you tomorrow.